In this video, I'm going to go through the basics of simplifying algebraic fractions, multiplying and dividing them, and adding and subtracting them. So fractions overall tends to be a type of numbers that students don't like to deal with, and then it gets a bit harder with algebraic fractions. So hopefully this video is going to clarify any misunderstanding and try to look for the tips. The best way I'm going to explain this section or this chapter is by going through as many examples as possible. So that's what I'm going to do, and I would encourage you to pause the video and try to solve some best you can. So just a typo here. So when we want to simplify algebraic fractions, we want to cancel out common factors. That's your goal. So if I, for example, have something like 21x cubed y squared over 14 xy cubed. Now I'm going to keep on asking myself the same question every single time I want to simplify algebraic fractions, which is everything being multiplied here? Yes, everything here is being multiplied with each other. There's no addition or subtraction, and everything is in a single fraction. It's not being added to anything. There's nothing being multiplied or divided. It's just a single fraction. Everything's being multiplied. That's important. Now, once things are being multiplied, numerator and denominator, only then can you cancel out the top and the bottom. And simplifying in fractions, you can only simplify things top and bottom. So you cancel common factors from the top and bottom. And you can think about it as dividing by the same number, top and bottom. For example, if I have 4 over 8, let's pick another number, let's say 4 over 18. Then I can say, I can simplify this by dividing the top by 2 and dividing the bottom by 2, and that will give me a 2 over 9, and that's the simplest it could go. So this is the idea, is that you are dividing, or you're taking common factors out. So this is what we're going to do here, and the way to do it with these simple ones is by considering the numbers separately and the letters separately. And again, we can only do it because we are multiplying and we're simplifying top and bottom. So first I'm going to consider the numbers 21 and 14. Well, I know that I can divide both numbers by 7. So I can divide these numbers by 7, divide by 7. So these will cancel out to give me 3 and 2. Now I will do these step by step, but as you do more of these, you are expected to do all of these simplifying steps in one line. So, sorry, this is 2. So now I have these two numbers. Now I can look at the letters themselves. And if you remember rules from indices, if you have x over, if you're dividing letters with exponents, then you are subtracting the powers. So this is going to be x to the power of 2. You're subtracting top minus the bottom. So 3 minus 1, so that's going to give me an x squared. So these are going to go, I'm going to get an x squared. And this is going to be 2 minus 3, which is going to give me a negative 1. A different way of thinking about this is if you have a higher power at the bottom, just remember that this is how this part expands, and so I can cancel out 2 y's from the top and the bottom, which leaves me with 1 y in the denominator. So in total, I'm left with a single y in the denominator, and so that leaves me with 3x squared over y. So all of this requires you to remember laws of indices. If you're not sure, please look at a video where I explain the laws of indices. So this is where it simplifies. So more straightforward, you look at here and you go 21 divided by 14, that would be 3 over 2. X cubed divided by an x, that would leave me with an x squared, the numerator. X squared, y squared divided by y cubed, that would leave me with a single y in the denominator. Sorry, I forgot the 2, and that's how it simplifies. So that's a simple more straightforward one. What if we have it slightly differently and we're looking at something that actually needs factorization? So if I look at x squared minus 16, for example, over x squared plus 2x minus 8. Now, you cannot cancel these two out. So I can't just cancel these two because things are being added and not multiplied. That's why I will keep on asking the same question. Is everything being multiplied? And can I cancel numerator and denominator? And the answer to my first question is no. Things are not being multiplied. In this case, I'm doing x squared minus 16. This is because the numerator and denominators have a hidden bracket in here. So at the moment, this whole thing is being enclosed. So I can't just deal with the x squared without dealing with the negative 16. So this is where it gets tricky for the student. So don't just simplify immediately. If you're unsure, you can always substitute in numbers and see if you're getting the same answer. Now, the way to go about it is to think, well, I can't cancel them out, but they still want me to simplify this, so the best way to do it is to factorize. And you need to start factorizing each one. I have a video on how to factorize the numerator and denominator, so I'm not going to go into too much detail on these, so please watch them. How to factorize the numerator, it's the difference of two squares, so this will be x minus 4, x plus 4. And simplify the denominator, this is factorize the denominator, this is factorizing quadratics. So again, do watch the video on this, and the factorization of this is going to be x minus 2, x plus 4. And now that I have things in brackets, these two are being multiplied and these two are being multiplied. So I can consider the bracket as my single number. So in here, we can go back to our first case. So this bracket could be the single 21, and this other bracket, x plus 4, could be our x cubed. So I can now deal with these brackets as separate numbers being multiplied. So we're back to the first example, kind of. And instead of thinking what cancels with x, now I have to think what cancels with x minus 4 as a whole bracket. And this is the trick you need to go for. So x minus 4, there's nothing that cancels with x minus 4. Well, what about x plus 4? And again, you can look at it as such because it's in a bracket, so you can, and this is being multiplied by that one, so you can consider them as like something a times a b, for example. And x plus 4, I have another x plus 4 here, so actually I can cancel these two out. Again, you don't cancel individual letters, you're not allowed to do that, but I can cancel out brackets because the brackets are being multiplied. And this is one of the tricks. So x minus 4 in the numerator, x minus 2 in the denominator, and that's as simple as it gets. I cannot cancel x and x, as this would give me an incorrect number, and again, these are all in a bracket. So if I want to cancel the x, I'd better have another x minus 4 here to cancel it with. So you can't just cancel them out. If you're unsure, just substitute for example, 3 in here, see what you get, and then try whatever you think is a simplified version, and try to substitute numbers in there and see what you get. And you'll notice that you'll get a different answer, which means that you can't actually simplify this any further. So this is the part of it. So I'm gonna put up just an extra example for you to pause and attempt. So if I have something such as 3xyz over 9x squared y cubed z to the power 4. This is a simple one. You can pause it and then look at the solution. So again, I'm going to look at the number, everything's being multiplied, that's the first question I ask, and then I can look at the numbers separately. So I can divide the numerator by 3, that will give me a 1, and denominator by 3, that will give me a 3. So in terms of numbers, I'm left with 3 in the denominator. In terms of letters, this x cancels out with this, I'm left with 1x in the denominator. This y cancels out with 1y here, so I'm left with y squared in the denominator. This z cancels out with 1z here, so I'm left with z cubed in the denominator. And it seems like nothing's left in the numerator, but remember everything here cancels out to a 1, so you're left with 1. So that's the answer. So that's the basics of simplifying algebraic fractions. The other videos are going to deal with how to bring them together as multiplications and division, subtraction, and addition, and then you apply whatever we've done in this video at the moment.